so we've got problems here that are all centered around old IB problems, or they actually are old IB problems. And this is a really popular topic on the IB exam to have you guys figure out some different equations of lines and do some different things with them. So what we've got going on here is the same thing we've been doing. We got to find the gradient, we got to find that point in the line, and then we'll have to plug them into the point gradient formula or point slope formula right there. And then we may have to manipulate them, move them back and forth, or do something along those lines. So let's jump into one of these here. So let's go down to number one. So it's going to give you an equation of a line. It's never going to be in the form you want. So it says for line L1, find the x-intercept and the gradient. To find the gradient, we have to get it in y equals form. So I'm going to take this equation, 3x equals 12 minus y, and I'm going to solve it for y. Probably the easiest way to do that would be to add y to this side and move 3x over here. So I'm going to get, that's gone, so y equals 12 minus 3x. When it's in y equals form, remember that the gradient or the slope is the number that's in front of the x, whether it's a fraction or whether it's a whole number. So the gradient is -3 or -3/1. Either one works. Okay, IB is not going to care which one you put down. X-intercept, this is a little trickier. All right, so x-intercept is going to have an x number and then a y coordinate of 0 because it's going to be on the x-axis, which means it's not up or down at all. So we would need a y value of 0. Best way to do this is to come over here to one of these equations, either your starting or ending one, and put a 0 in for y. So it doesn't really matter which one I use. I'll use the one I just got. So it's 0 equals 12 minus 3x. And then we just solve for x. So minus 12 minus 12. -12 equals -3x. So x equals +4. All right, so that means my y-intercept is 4, 0. All right, now I could have put that in my calculator and graphed it and found it that way. Whatever way is the easiest thing for you to do. So then it says a second line intersects the x-axis at P20 and is parallel to L1. Find the equation of L2 giving your answer in that form. So we need a slope and a gradient to find an equation of a line. A slope and a gradient, the same thing. A gradient and a point. So it gives us the point right here. So 1 is the gradient, 2 is the point. So the point is 2, 0. All right, that's x1, y1. The gradient, if it's parallel, needs to be the same. Well, the gradient of that is -3, so the gradient of this is -3. You can use the fraction if you want to. There's no need to, though. Then I look the formula up, and it's y minus y1, which is y minus 0, equals m, which is the gradient, times x minus x1, which is x minus 2. Now it wants it in this form. This is a rare thing right here where the form actually comes right out from what you did. Y minus 0 is y. So it's y equals, and then I need to make sure I multiply that. So it would be -3x plus 6. So that would answer that next part. Then it says calculate the y-intercept. Well, the good thing about this form is the y-intercept is the number that you get at the end of that form. That's what the c is. So the y-intercept has a y coordinate of 6, and the x is going to be 0. Okay, again, you could put that in the calculator if you wanted to and find it that way. But any y-intercept has an x coordinate of 0 no matter what.